Thank you. All right, yep. Thanks for the introduction. My name is Ann Garber. I'm the utilization payload team for HLS, and I'm going to give you an overview of some things happening in the program, as well as some more information about what my team specifically does within the program. All right, so as you can see here, we do have a fleet of HLS missions with opportunities for utilization, and it's going to look maybe a little bit different from what you may have seen before. I know some of you have seen this chart before, given the recent announcements. The first lander that will touch down on the surface of the moon will be Starship's uncrewed demonstration. So we are in the process of working with SpaceX to determine the feasibility of including some specific utilization payloads on that vehicle. December 2025 will feature, of course, the return of humans to the moon for the first time in more than 50 years, and we'll be using SpaceX's Starship for that trip. Artemis 4 will be the second flight of SpaceX's Starship, currently slated for 2028, and also in 2028 will be the uncrewed demo for Blue Origin's moon lander, which will be followed by the manned Artemis 5 flight and landing of Blue Moon in 2029. All right, so our first partner, of course, is SpaceX, and they will be providing landings on the moon via Starship. And we have awarded 2 contracts to SpaceX. The first is Artemis 3, and that includes both the crewed landing of the next 2 Americans on the surface of the moon, as well as the uncrewed demonstration flight that precedes it. So Artemis 3 crewed demo will feature docking with Orion. The second contract is for Artemis 4, and this contract further develops HLS Starship to an extended series of requirements for longer service duration, and that mission will feature docking with Gateway. We did want to point out that Starship is able to fly mass and volume that's in excess of the threshold requirements for this. So we have been working with SpaceX, of course, to incorporate utilization payload mass and volume into that excess capability. We will be using some of that excess for utilization payloads. All right, so here's some pictures of our team interacting with SpaceX's Starship team. And on the left, you can see right in the middle, that's our program manager, Dr. Lisa Watson-Morgan, in the red shirt. She's taking a look at one of the grid fins that are deployed on the Starship booster when it returns to Earth for landing. On the upper right, we've got some team members taking a look at a prototype of the elevator. And on the lower right, I think that's Pam Melroy on a Starbase tour with, I believe that's Gwen Shotwell. So both the NASA HLS and the SpaceX HLS teams have worked very hard to build a strong working relationship. So we work and talk together all the time. We travel to SpaceX locations routinely for meetings and events and things like that. And I think our efforts have really paid off. We don't want this to be a situation where the left hand doesn't know what the right hand is doing. We do work very well together, and I think that together is the operative word there. So here's the new stuff. Let's see. So now, as most people, and probably everyone on this call is likely aware, NASA did announce last week the selection of Blue Origin as our second partner to provide a human landing system that will meet our plans for regularly occurring long-term access to the surface of the moon. The contract award includes both an uncrewed demonstration mission and a crewed demonstration mission, which is the Artemis 5 flight. And the Blue Origin team architecture does consist of both the Blue Moon lander and the Lockheed Martin cislunar transporter. And you can see there's multiple other partners. You've got Draper, Boeing, Astrobotic, and Honeybee Robotics, which are all providing various systems and engineering functions to support Blue Moon. Excuse me. Well, I'm sure there are a lot of questions about Blue Moon. The chart does contain pretty much everything we can say about the lander at this time because we're still in the blackout phase, I think for roughly another week, give or take. So we can't really engage with Blue Origin until the blackout period is over. But we're really excited to work with them, and I'm in particular excited about getting to talk to them and find out more about what their utilization capability looks like. Once we do engage with them, it's probably going to be a few months of internal HLS work, NASA HLS work to adjudicate requirements. So we won't have much to share, I think, about actual utilization capability for maybe until sometime this fall. But I know everyone's going to be waiting on tenterhooks to learn more about what they can do. So that brings me to the HLS utilization payload team, and that's where I work within the program. I did want to point out that in this case, when I talk about utilization, that does mean an encompassing of science, tech demos, human research, and in situ resource utilization. Our team supports all aspects of utilization payload integration with both lander providers. So we have many functions, this really are just a few of them, but one thing I want to point out just off the top is that we do advocate for utilization payloads back to the program. In other words, we are speaking up on behalf of payloads, and we're looking out for what you need. We do engage with the science and the research community on payload development, and there's more to it than is listed here, but just for some examples, while we interface with the Artemis internal science team, which is an SMD, we will assign HLS POCs, one POC, to work directly with each payload. And if you're familiar with how that works on payload integration for the International Space Station, the way they use payload integration managers, the idea is that that would be a pretty similar thing happening here. We also provide support for payload feasibility assessments. And if there are payloads that want to figure out early on whether flying on HLS can be supported just from a technical standpoint and while also meeting their science goals, that's something we can provide. We develop payload interface requirements both for the vehicle and the flip side of that being the payload side of the interface. And not only do we work with the lander providers to develop to interpret our requirements and develop the interfaces on the lander, but we also support the work of the Artemis Utilization Interoperability Working Group, the AUIWG, which is working to define payload interfaces that are intended to be common across multiple vehicles. Of course, the idea there being that you could take a payload off of one vehicle and put it on another vehicle while not really having to do any adapting. It's sort of a plug and play kind of idea. We do support the Moon to Mars office and cross-program activities that do relate to utilization payloads, and that includes developing some interface requirements, as I've already mentioned, as well as things like working to support the development of payload integration agreements and supporting the integration processes themselves. And our team will also provide support for payload operations. That includes science, mission planning, training, procedure development, and providing ground operators. And there's a bit more information about the facility where this is done on the following slide. So many of you will already be familiar with the Huntsville Operations Support Center, or the HOSC, if you've been involved in SLS or ISS. Obviously, that's been supporting ISS payloads for many years. The plan is to use the HOSC in a similar way to support Artemis payload operations. So the HOSC does support the HOSC does serve as a ground systems operations facility 24 hours a day, 7 days a week, 365 days a year, multi-mission, can support multiple missions at once. The team there prides itself on providing user-oriented services that are very reconfigurable. Those are based on specific users' needs, and they can provide custom solutions for your particular mission requirements. The facility does provide secure and centralized services, as well as common infrastructure for a user community that is dispersed across the globe. So lots of experience in that area as well. Ops are supported via 5 configurable control rooms. You can see some pictures there on the right of some of these. That one at the top is probably the most familiar to anyone who knows the HOSC facility. That's that, if you go on a tour, that's the one you'll see where the main cadre for that control room sits and supports ISS payload ops. I think the second one is another reconfigurable control room that was used to support SLS most recently. And below that would be the Lunar Utilization Control Area, or LUCA. That's a room that's been being prepped for the past few months. And if it's not done yet, it's getting pretty close. That is one room that would be used to support HLS payload ops. There's another room called LISA, coincidentally, of course, with our program manager, but that's the Lander Engineering Support Area. Again, another control room we can use to support Artemis payload ops. And the HOSC has supported several programs over the years in ways that are relevant to HLS. That includes programs like ISS, SLS, and Commercial Crew. And they're currently in the process of preparing to support Gateway. HOSC will be providing payload ops support and planning for Gateway payloads, and they will also serve as a data and comm node for Gateway payloads. And if you follow the QR code, I believe that takes you to a NASA HLS webpage.